Good morning to all. So we are discussing about a subject called as design and analysis of algorithm. We know that algorithm in the sense step-by-step solution or step-by-step procedure, step-by-step procedure itself. So how the step-by-step procedure is created? So creation is nothing but a design. Once we create the algorithm and how that algorithm is analyzed. What do you mean by the analyze? Whether it is matching the requirements, whether it is taking a much time, whether it is taking a uh, much space or lesser space. So this terminology is based on the factors called as requirements, much time and much space, or less time and less space. So then we'll tell that it is a good or bad algorithm. We cannot call it as bad, but in the terms we may call good and bad algorithm by analyzing the time and space. Time and space. So that is what analysis of algorithm efficiency. How much my algorithm is efficient. The terminologies measures the efficiency is time and space. This is what I think we had a discussion in the first slide, the very first slide here. Now we'll move to the next slide. There we had discussed introduction. So first question is why we need to develop algorithm. Simple answer, we have to write the program. We have to write the program to get my particular answer. If I find out in the GSD, greatest common divisor, then I need to write a program. Before writing the program, I need to write a common solution, that is a algorithm. So why I am developing algorithm? I am developing algorithm to write a program and to get the perfect answer. Yes. Now as I know that all the programs may not take reasonable time. Reasonable time in the sense, if P1 and P2 are there, program 1 and program 2 are there, both are computing GCD itself using different methodologies. It may take a 2 milliseconds to give the result. It may take a 15 milliseconds to give the result. It depends on the methodology which is used to implement that program. That is, it is depend on algorithm which is used to implement this program. If I use X algorithm, it may take a 1 millisecond. If I use a Y algorithm, it may take a 15 milliseconds. But I am finding out the same problem, that is a GCD problem. So all the programs, all the methodologies are not having the same time. So then the calculating the time taken by the algorithm. So if X algorithm is taking a 1 millisecond and Y algorithm is taking a 15 millisecond, then calculating the time taken by algorithm is known as analyzing the algorithm. Based on the time, we are measuring that which one is good now. If it is taking 1 millisecond and if it is taking a 15 milliseconds, so which one is greater here? So this one is greater in the sense it is taking a much time. So it is not a good algorithm. X is a good algorithm. So we did an analysis on the X and Y algorithm here. So now how the analysis will be done, how the efficiency will be calculated, that is space efficiency and time efficiency. What do you mean by the space efficiency? We are going to learn today itself. Well, hope guys you remember, or you may not remember. I will repeat once again, that is space complexity and space efficiency. My question arises, what do you mean by the space efficiency? You all know that when program is developed, when program is developed, we press or we will run the program. What do you mean by the running program? We'll run the program, we'll compile, we'll execute the program. Okay, what do you mean by the execution? When you develop and save the program, it is present in the secondary memory. That is, it may present in a hard disk. Sir, I will write a program. I had written a program, then I will save it. Control S, I will press save it. Control plus yes, that will be saved in secondary memory. Okay, once I run the command, which is to execute the program. Assume that if it come to the what we call turbo C, we'll use run. If I press run, it will be executed. What do you mean by the execution? Execution in the sense bringing the program from secondary memory to primary memory. It is called as a execution. It is called as a execution. My program is stored in the secondary memory, then it will be brought to the main memory or a primary memory. Which is the main memory or primary memory? That is RAM. Okay. Now, when I bring that program to my primary memory, how much memory it will consume? As I told, I will write a program and I will save it in the secondary memory, and at that time when I press the run, at that time the program will be loaded onto the main memory. Okay, how much space it is required in the main memory? That is what the amount of yes, how much memory required, that may be required to run the program. That is, if the memory which is required in the main memory, that is space required in the memory, is called as a space complexity. It is called as a space complexity. Okay. uh, well guys, uh, I bought this one into the main memory. That is amount of memory that needed to run the program. This space, if it is a 12 KB, if it is a 12 KB, then the space complexity of this program is 12 KB. Just I am telling you, it is not a method to find the what we call space complexity, but just purpose of understanding this point, we are doing this one. So, without sufficient memory, program may not run. The program requires 12 KB, but I am available with only 11 KB. So, it is not possible to run the program. Okay. So, insufficient memory leads to the wrong output, or it may give error. Okay, at that time, so we need to think, when I am developing an algorithm, developing an algorithm, that algorithm used to program something. At that time of designing algorithm, I need to take care of the size of the memory. I need to take care of the size of the memory. So simply we cannot make anything. Assume that we'll take an example. There is a space, there is a space, what we call, assume that 25-meter space is there, where you can park your uh, some vehicle and right correct, some vehicle you will park. Its size is 24 meter. The size of the room is 25 meter. Yes, your vehicle size is 24 meter. Now easily it can fit here, easily it can fit here. Same, this is a room where your vehicle is standing, whose size is 24 meter, and the room size is 25 meter. It is easy. I am not wasting much space here. I am wasting a only 1 minute, 1 meter. If the room size is, if the room size is 30 meter and your vehicle size is 24 meter, so it is wasting a 6, how much, wasting a 6 meters of space. Assume that, assume that your room size is 23 meters and your vehicle size is 24 meter. It won't fit here. Why you are telling it this one, sir? Yes, I'm telling because I have to think when I am preparing the room itself, how much room I have to build here to park my vehicle. At that time of designing the algorithm, when we are creating the algorithm, at that time itself, we need to take care of the memory requirement also. How much memory it will consume, how much less memory it will consume, it is very efficient. It is a very efficient. This is what my space complexity introduction. This is what my space complexity introduction. Hope you all are clear. I'll move to the next slide. I'll move to the next slide. Wait for a while. Yes. Analysis of space complexity. Before going to that, we'll understand some terminologies here. What do you mean by the terminologies? So my question is that how I may get the memory requirement, that is a space requirement. As we are telling that we need to, as we are telling that we need to calculate the space complexity at the time of design itself. At the time of design itself. Okay. How we are going to get it, sir? Yes, if I am writing a problem, if I am writing a solution for a particular problem, yes, I will go through the requirements first. That is, I may get variables here. In this solution I may get a variables, very good, and a program instructions. Instructions in the sense lines, statements, program instructions, and finally I may execute this solution. So these are the main terminologies. Whenever a solution to the problem is written, whenever the solution problem is written, some memory is required here to complete that one. We know that one program ಬರೆದ್ವಿ ಅಂತಂದ್ರೆ, if I write a program, a memory is needed to complete that program execution. Yes, ಅಂದ್ರೆ ಅರ್ಥ ಏನು? If I write P1 as a program, without the main memory or a memory, it won't give the result. It won't give the result. Hence, if I write a program, the memory will be needed to the produce the result. The memory is must and should need the result. Yes, to complete that process. Yes, algorithm ಒಳಗಡೆ ನಾನು memory ಎಲ್ಲೆಲ್ಲಿ ಯೂಸ್ ಆಗಬಹುದು? I may use a memory in a variable, program instructions and execution. These three are the main terminologies where memory is used. Main memory is used. Well, now you know already what is a space complexity. Very good. You know already what is a space complexity. What do you mean by the space complexity? Yes, I have written one program, sir. That program will be loaded into the main memory or a memory. The space required by that program is called as a space. That is space. ಇದನ್ನ ಹಿಂಗೆ ಅನ್ಬೋದಾ? Space is the amount, space complexity is the amount of memory used by the algorithm. Why algorithm, sir? Why not program? Because we are loading the program, no? We are loading the program, no? Then why we are considering it as an algorithm? Yes, because how this program is implemented, on which basis? On which basis? The base is your algorithm. The base is your algorithm. Okay. So then the space complexity is the amount of memory needed by the algorithm is known as a space complexity. Yes, sir, we got this one. Not only this, my dear, you need to remember another word, that is auxiliary. That is auxiliary space. See, it is not in the syllabus, but you need to understand this one. ಲಕ್ಷಿರ್ಲಿ ಇದು ನಿಂಗೆ ಆಕ್ಸಿಲರಿ ಸ್ಪೇಸ್ ಅನ್ನೋದು ಎಕ್ಸ್ಟ್ರಾ ಥಿಂಗ್ ಹೇಳಕತ್ತೀನಿ ನಾನು ನಿಮಗೆ. ಓಕೆ, ನಾವು what do you mean by the auxiliary space? Don't confuse that space complexity and auxiliary, that is a space and auxiliary space are same. Don't get confused. Auxiliary space ಮತ್ತು space ಎರಡು ತರ ನಡಬರ್ಕ difference ಬಾಲದ. Space complexity and auxiliary space. What is the difference, sir? Space complexity ಅಂದ್ರೆ ಏನು? The space complexity means the amount of memory needed by this algorithm. Very good. That is, some memory part is there, sir. That memory part will be utilized by this algorithm or used by this algorithm. That is called as a space complexity. I will write SC here. Yes. Now auxiliary space in the sense, yes, we'll study that one. Now assume that my algorithm A1 is executing, that is, it is present in the main memory. In this algorithm I used one variable called as a A. See, concentrate on my words. A1 is executing in the sense it is in the main memory. Okay, now A is there which is not present in the main memory. Why? Because it is called at the end of the program. So it is not necessary to put this A here because it is unnecessary anta use ಮಾಡ್ತೀನಿ ನಾನು. ಇದು ಎಷ್ಟು ಸಲ ಕಾಲ್ ಆಗ್ಲಿಕತ್ತದ? ಒಂದೇ ಸಲ ಕಾಲ್ ಆಗ್ಲಿಕತ್ತದ, ಅದು ಲಾಸ್ಟಿಗೆ ಕಾಲ್ ಆಗ್ಲಿಕತ್ತದ. ಸೊ ಅಂತ ಟೈಮ್ ನಾನು ಏನು ಮಾಡ್ತೀನಿ, ಇದನ್ನ ಸಪರೇಟ್ ಇಡಬೇಕು ಅಂತ ಯೂಸ್ ಮಾಡ್ತೀನಿ. ಐ ವಾಂಟ್ ಟು ಪುಟ್ ದಿಸ್ ಕೈಂಡ್ ಆಫ್ ಥಿಂಗ್ಸ್ ಸಪರೇಟ್ಲಿ. So the extra space needed for algorithm to store some values like this, that is auxiliary space andre enu, extra space or a temporary space. Once A will be removed, this space will be removed. This is temporary space. The temporary space needed by the algorithm is called as a auxiliary space. Now nodri, space complexity heng calculate ಮಾಡ್ತೀರಿ? If algorithm is with auxiliary space, it is having 5 kb of space complexity ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಎಷ್ಟು ಸ್ಪೇಸ್ ತಗೊಂಡೈತಿ? 5 kb ತಗೊಂಡೈತಿ. And auxiliary space is 2 kb. Now tell me complexity. So totally the space used for input is 5 kb and the total is used for what we call auxiliary space is 2 kb. So in the sense, space complexity is equal to this memory is used for input space plus auxiliary space. So if I add input space with auxiliary space, I will get a total space complexity. Okay. Yes, I will come with the instruction space here. I had written a program P1 based on the A1. Algorithm 1 is implemented as P1. Algorithm is a general programming language. Will be using some PLs, that is programming language. I have implemented one program by using A1 algorithm. That may perform anything. Assume that it is performing a plus B. Assume that it is performing a plus B. Based on the algorithm A1, I have implemented a P1 here. Very good. Now, what I am going to do before execution? What I am going to do? I am going to compile it. Yes. What do you mean by the compilation? The programming language is compiled to machine language. So that is called as a compiled code. Once program is compiled, the code will be generated. the compilation code will be generated. Yes sir. ಯಾವಾಗ ನಾವು ಒಂದು ಪ್ರೋಗ್ರಾಮ್ ಅನ್ನ ಕಂಪೈಲ್ ಮಾಡ್ತೀವಿ ಅಲ್ಲಿ ಮಷಿನ್ ಕೋಡ್ ಜನರೇಟ್ ಆಗುತ್ತೆ. ಯಾರು ಜನರೇಟ್ ಮಾಡಿರ್ತಾರೆ ಅದನ್ನ? ಕಂಪೈಲರ್ ಜನರೇಟ್ ಮಾಡಿರುತ್ತೆ. Yes. When I compile my program, the machine code will be generated by the compiler. Yes. To store the compiled code in the memory, a space will be there, that is instruction space. ಒಂದು ಪ್ರೋಗ್ರಾಮ್ ಕಂಪೈಲ್ ಆದ್ಮೇಲೆ ಜನರೇಟ್ ಮಾಡ್ತಕ್ಕಂಥ ಮಷಿನ್ ಲೆವೆಲ್ ಅಥವಾ ಮಷಿನ್ ಕೋಡ್ ಅನ್ನ ಸ್ಟೋರ್ ಮಾಡಲಿಕ್ಕೆ ಒಂದು ಸ್ಪೇಸ್ ಇರುತ್ತೆ, that is a instruction space. When I compile my program, the machine code will be generated by the compiler. To store that generated code, I am having a space in the memory, that is an instruction space. If I consider this one as a memory, the space this one is used to store the compiled code. Yes. Now sometimes what happens, I will declare int I. What do you mean by the int? It is going to represent a data type and it is going to represent a variable. Yes. So now what this is showing? So this is showing that it is a data. Data in the sense the variable where we can store the value. What do you mean by the value? The value in the sense information itself. Now information is referred as data, no? Yes. So such kind for variables, constants, I am having a special space, that is a data space. Instruction space, here I am storing a machine code. In data space I am storing a variables and constants. Now what is the stack space, sir? We'll come up with that one. Stack space in the sense, I will write one function. Area is equal to a comma b. Just I am telling c is equal to a into b. Now return c. Now c is a variable, no? Where it is stored? It is stored in the data space. Somewhere else its address is, assume that c's address is 201. Nodra, c is a variable, it is stored in a data space. Now it is returning c. It is not returning c, it is returning the address. Yes, where the return address is to be stored? It is stored in a stack space. That is, to store the return address or return values, we are going to use the stack space. Instruction space in the sense we will be storing the machine code. Data space in the sense we will be storing the variables, statics, context like things. Stack space in the sense we will be storing the return address or return values of the variables or the things. So further, it is not completion of instruction space, data space and stack space. It require another half an hour to complete this one. Yes, this concludes the class here itself. Thank you.